Hello friends, hope all are doing well and I am here with the third video of surge protective devices. In the first video I discussed about what is surge and what is the causes of surges and what are the impacts of surge in the electrical power system. In the second video I discussed about two different types of surge protective devices. One is um, spark gap type, another one is gas discharge type. These two type of surge protective devices are coming under the category of switching type, where we have two electrodes. When the high voltage spikes are created or the surges are created, the electrodes between the electrodes there is arc formation, and when the arc formation is done, then the current flow takes place through these electrodes to the earth or ground. The problem with these two type of devices, surge protective devices, are it needs very high voltage to create a arc between these electrodes. And once the arc is formed, quenching those arc is difficult, and it creates a flammable gases in sometimes, and it creates fire hazard. And also it needs more time for starting this process. So these are the few drawbacks of these two devices. Though there are few advantages because these devices can be used for very high voltage or a very high current surges. Today we are going to discuss about metal oxide varistor, so which is nothing but a regulating type of surge protective device. As I told you, those two devices are switching type and this one is a regulating type. Let us understand how it is going to work and how it is different from other two type of surge protective devices. Metal oxide varistors are simply varistors or nonlinear surge suppressor devices which are used for suppressing sudden high abnormal voltage transients or surges, especially during power switch on or thunder lightning situations. At very low voltages, MOV has the ability to indicate that conduction is blocked. So at very low voltages, that means at the normal operating conditions, the MOV acts as an open circuit. And when the higher voltages are applied due to the surges, that particular time, the resistance of these MOVs are going to non-linearly reduce, and when it is reduced to a certain extent, then it will start conduction. So this process of conduction is going to provide a path for the surge current to the ground. So this is how the MOVs are going to divert the surge current or the surge voltages to the ground potential. So these are the few varieties in the market. I have a surge protective device in my hand. So this is a metal oxide varistor which you are seeing on the screen, as well as here in my hand. This is one type of surge protective device, and usually it is connected in parallel to the circuit which has to be connected, which has to be protected. You can see here the symbol of the metal oxide varistor also is shown here, and the graph here it shows how it reacts with respect to the voltage and the resistance. When the voltage increases, when the voltage increases across these varistor, then automatically the resistance keeps decreasing. At one particular time, it allows the free flow of current through these varistor, so that means it acts as a closed switch so that it can divert the all surge current. At particular certain voltage levels, it blocks the full current path where it is acting as a open circuit. So that is our normal operating condition. Constructionally, what it contains is it is almost like a capacitor. We have two plates and we have certain materials between them. So those materials are nothing but a ceramic powder made up of metal oxides like zinc oxide and some other metal oxides like oxides of cobalt, manganese, and bismuth. So MOV consists of approximately 90% of zinc oxide and small amount of other metal oxide. How it is packed? So the ceramic powders of the metal oxide are kept intact between two metal plates called the electrodes. Same like our capacitor. The grains of metal oxide create a diode junction between each immediate neighbor. So an MOV is a large number of diodes connected in series. So when we have this metal oxide tightly packed, it is behaving like a diode junction. And when we connect more number of diodes together, it is acting as a series of diodes connected in series connection. When you apply small voltage to the electrode, a reverse leakage current appears across the junction. Initially, the generated current will be But when a large voltage is applied to the MOV, the diode's Barter junction break down due to electron tunneling and avalanche breakdown. So at this point, it allows the current flow through this device. So these are the few applications where you can see the MOV is connected between line to line. So where the circuit to be protected is here, and when the power surges are coming, so the potential is applied across this MOV, the variable resistor. So when the high voltage is coming, it will divert to the neutral path, and the current will be passed through the line to neutral here. And we have here line to neutral and line to earth protection as well. In the first case, it is between line to neutral, and here we have line to earth and neutral to earth. When the power surges are created between the line to earth, so it will be bypassing the high voltage to the ground through this path. And if it is between line to neutral, so it will come through this path. And if you have the transistors to be protected, so we can also have the MOVs connected parallel to the transistor, and the relays also can be protected using this MOVs connected parallel to these devices. So these are the few applications of metal oxide varistors. Hope it is clear, and it is very simple concept. Any doubts, please let me know in the chat box. In our next video, we will discuss about TVS diode